Alright, the practice test. So, 4 questions. First question, this covers all of chapter 3 stuff. First thing you gotta do, if you're given this frequency table, you gotta total each column and you gotta total each row. So, the data kind of displays opinions depending on the region in the United States they come from. So, the Northeast region, you sum these 3 entries and you get 722, blah 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 blah. Then if you sum all the regions, they equal 2,099 people. So 2,099 people were surveyed. And if you sum all of the opinions, the very important, that's 1205, 752, 142, those also sum to 2,099. So we got a total of 2,099 people surveyed. So A, what are the chances that you randomly choose someone and they had an opinion of somewhat important? So somewhat important could be any of these 4 regions. So that sums to 752 out of the 2,099 thought that their opinion was somewhat important. B. Okay, B is conditional probability. So this vertical bar indicates conditional probability. Conditional probability totally shrinks the sample space. So what are the chances you're going to run into someone that had a not at all important opinion, given that they're from the South region? So now you are only looking here at the South. This is the only region you're looking. So you're only looking at these 844 people. And what are the chances that they had an opinion not important? So that is 76 out of the 844. Okay, now let's do C. What are the chances that you run into someone from the West region and someone important opinion? So the West region is, let's see, here we go. The West region is right here. Oh, that's a little thick. Okay, the somewhat important region is, or the somewhat important opinion is all these guys. Okay, so they have to be from the West, and they have to have an opinion somewhat important. So that kind of narrows it down only to, and is intersection, so that's where they overlap. They overlap, those 98 people overlap. So C is 98 out of the 2,099. D, what is the chance you run into someone that had a very important opinion, or they're from the Midwest? Okay, or is union, so it's not intersection. Alright, so or, here we go. Very important opinion, that's the top row. Or the Midwest, so that's all these guys. So you take, so if it's or, it's either or. You win if you have a Midwest region, or you win if you have a very important opinion. So these guys are winners, these guys are winners, 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 winners. Anything highlighted is a winner. So you're going to take all of the very important people, that's 1205, plus you're going to take all the Midwest people, that's 219, but you're going to subtract, these guys were double counted. So the intersection, they're always going to be double counted, only count them once. So take away the 129, add those up out of 2,099, and that is your answer. Okay, next one. Let's erase this. We're on E. Okay, E. Okay, complement. So the probability of A happening and the probability of A prime. So this is complement. So this would be the total opposite, the chances of A not happening. So what is the complement of not important at all? So the not important at all, doesn't matter the region, there are 142 out of the 2,099 that were not important. So the complement is the total opposite of that. So it's going to be the 2099 minus, it's going to be everybody else, minus the 142, 2099 minus 142. So that's going to be 1957 out of 2099. Okay, F. F, what are the chances you run into someone that had a very important opinion? And this is the same as B, it's conditional. So now you're only looking at, it's going to reduce the sample space. So instead of looking at all 2099, you're only going to look at a certain portion. Okay, you're looking at the portion here, south or west. So you are looking at all of these guys right here. And that was an 8 once upon a time. Okay, so now out of that region right there, what are the chances the people had a very important opinion? And that's going to be these two right here. So it's going to be 456 plus 195 over the 844 plus the 314. Okay, whatever that simplifies to, that's your answer. G. Are there any events that are mutually exclusive? So mutually exclusive has no overlap, no intersection. They can never intersect. They cannot exist at the same time. Okay, so this is an example of mutually exclusive. So when I talk about overlap, I'm talking about intersection, kind of an Venn diagram, that's where they meet. But if we look at the very importance, or we look at the northeast region, that is called an overlap. That's an intersection. So they cannot exist at the same time. You can be from the northeast and you can have a very important opinion. Those two things can be true at the same time, so they are not mutually exclusive. Or they are. They're not mutually exclusive. This is mutually exclusive. The chances that you are from the northeast and you are from the Midwest. So you cannot be from the region northeast and at the same time be from the region of Midwest. Here's another example. They want two examples. You cannot have, so the chances of you having a very important opinion and you having a not at all opinion, those two cannot exist at the same time. You either have one or the other. You cannot have both. So G, there's lots of events in there that are mutually exclusive. H, okay, H. Are any of these events dependent? So independence is kind of hard to prove. If you cannot, you kind of always assume things are dependent unless you can prove they are independent. To prove they're independent, you use one of three tests. So the probability of A is the same thing as the probability of A given B. Or the probability of B is the same thing as the probability of B given A. Or the probability of A intersect B. So the intersection, the overlap, is the same thing as the probability of A times the probability of B. So we're going to assume these events are dependent. So let's look at this. Probability of northeast. Okay, probability of northeast, that was 722 out of 2099. And let's look at the chance of you having a very important opinion. Very important opinion is 1205 of those people had an important opinion out of the 2099. Okay, so if you find success with one of these three events, then they are independent. Okay, so we kind of got to check them all. But this is only going to take a sec, it's not bad. So let's start at the top. So the probability of A. So I'm going to let this be A, and I'll let this be B. So the probability of northeast region is 722 over 2099. Is that the same as the probability of A given B? So probability of A given B, so the given B is the very important opinion. That's all these guys. And what are the chances that you come from the northeast? It's going to be 425 out of 1205. And those two are not the same. So they're not independent according to that test. And if we check it with this one, they're not. If we kind of reverse them, if we do the probability of B given A, let's check the last real quick. Probability of the intersection, so the intersection of the northeast region and the very important is 425 out of the 2099. Is that the same as the probability of A times the probability of B? So this value times this value, and the answer is no. So they're not independent, so they must be dependent. So here are two dependent events. The probability of coming from the northeast region is dependent on the probability of having a very important opinion. Those two events are dependent. They are because they do not pass the tests, the three tests for independence. Okay, so number one is done. Number two, this comes from chapter 4, lesson 2, expected value. Okay, so expected value. Professor Borgero pays $75 a month for a $100,000 life insurance policy on his wife. The statistical tables show that she has a 0.83% chance of dying in the next year, so it's less than 1%. What is the expected value to Professor Borgero for this life insurance policy for the next 12 months, so for the next year? Okay, here we go. So we're going to make this table. Here is what is happening. So capital X is some random variable, and the English is the amount of money won or lost. So then little x takes on two values. Little x takes on, you're either gonna gain 100 grand or the other option is your wife lives and you're gonna have to pay $75 a month for 1 year. So 75 times 12, you are out $900. So these are the two values that x is going to take on. Okay, so that is x. So x is 100 grand or a negative $900, and then I'm just going to put this in 100 grand. That happens if your wife dies. You pay $900 if your wife lives. Okay, now this next column is going to be the chances of x happening. So what are the chances that you're going to get 100 grand? Well, she has a 0.83% chance of dying, and if that happens, you get the 100 grand. So 0.83 is 0.0083 as a decimal, and its complement is going to be 0.9917. So you got a 99% chance that you are going to live, so that you're going to have to pay that much money. Now here's what we gotta do. These values totally depend on whether or not you should play the game. Because if this number is large enough, even though the chances are small, this number might be large enough to make it worth your while to play. So this next column, you're going to take and you're going to find the average of this. You're going to times them. So x times the probability of x. So I'm going to take that 100 grand times by the chances of that happening. 100 grand times by 0.0083, and that is 830. Take the negative 900, times that by 0.9917, and that is negative 892.53. Okay, so now the last thing we're going to do is the expected value. We're going to sum all of these events, and there's really only two events. There's only two things going on. So we're going to sum them. So 830, I guess we could just add them up right here. Dun, dun, dun. That guy plus 830. So it is a negative 6253. So the expected value is a negative 6253. I mean, so chances are you're out money. You're out 62 bucks, which, I mean, it's not a lot compared to 900 bucks, but that's because the payout is so large. If you do win, you're winning 100 grand. So if this were like $1 million, then definitely the expected value is going to come out in your favor and you're going to want to play. Okay, number 3. Number 3 comes from the next lesson. This is 4.3. So after a mass shooting last week in Las Vegas, some are calling for stricter gun laws in Utah. 38% of the voters are in favor of stricter gun laws. A random sample of 10 Utahns is taken. Showed that this is a binomial experiment. Okie dokie. So, binomial experiment. Okay, X. So this little tilde means it's going to be some kind of distribution. It's going to be a binomial distribution. And you put N and P. So you got to remember this. N is the number of trials. P, so binomial means there's only two options. It's a success or a failure. N is number of trials. P is success. And Q is failure. Alright, so here we go. A, it's going to be a binomial distribution. So X is a random variable with a binomial distribution. That's what the B indicates. The number of trials is only 10, so not many. P, looks like it is a 0.38. So we got a 38%. And there we go. That's kind of A. B, they want us to make a table. So I'll start you off. We're not going to do the entire table. Let me erase this. But let me show you how to do the table. Okay, so our table is going to have really only 10 entries. So okay, so X could be like these number of samples. Well, I guess we should maybe change them to N's. Who knows? Doesn't matter probably. And this is the probability of that. So this is person 1, person 2, person 3, person 4. Let's just do 5. Okay, now I want to know. So in Utah overall, 38% of the voters are in favor, so that's not many, that's not even the majority. So the minority are in favor of stricter gun laws. So if we randomly run into 10 people in Utah, what are the chances that one of them is in favor of stricter gun laws? So here we go. It's going to be calculator. We're going to go menu. Well, I gotta add a calculator. Okay, now we're gonna go menu 5. We're gonna go probability, and it's a distribution, and it is a binomial, and it is a binomial probability distribution function. It's a PDF. Okay, number of trials. There are going to be 10 trials. What is the success? That is 0.38. And the x value is going to be 1. I just want to know the chances of one of them being in favor. Okay, so that one is a 0.05144. So I forgot what it was. 0.05144. 0.05144. Okay, number 2. What are the chances that 2 of them will be in favor? So let's do the same thing. And I'm just going to go up, up. I'm going to copy and paste that. Then I'm going to go change that 1 to a 2. You got to do this 10 times. 0.1419. So this is 0.1419. What are the chances that 3 of them will be in favor? Dun, dun, dun. So I'm going to go up, copy paste it. Let's change that to a 3. And hit enter. 0.2319. 0.2319. 4 of them. And we'll stop on this one. Oh, we gotta go to the 5th. We gotta do one more. Okay, 0.2487. 0.2487. I think it's gonna jump out the next one we do. If we go up, hit enter. Let's delete that. Change it to a 5. Okay, there we go. 0.1829. 0.1829. So the probability looks like it peaked out at 4, which is going to be good because that's about right. About 40%, 38% are in favor. So the chances that you sample 10 people and 4 of them are in favor is going to be like 24%, 25%. But then if we go 5, it's going to start to get smaller and smaller. And when you get to 10, we can do 10 real quick. 10 is going to be way small. Okay, 10. So the chance that all 10, yeah, so move that decimal 5 times to the left, so 0.000062, so that's way small. Okay, so that is B. Let's make a table. Okay, I think C is the same as A. I might have done C already. So make a probability distribution. That is this. There's a random variable x with the binomial distribution with the parameters. We're going to have 10 trials, and each trial has a 38% chance. So that's the answer to C. Okie dokie. Now, calculate the mean. Let me erase this stuff right here. So the mean for a binomial distribution. So binomial, let's go here on your review. So this is a formula I'd put in your note card. Where are we? 4, 3. So 2 formulas. The mean is kind of straightforward. Here is the mean. You just take the number of trials times the probability. So, I mean, if the probability is 38%, and I'm going to sample 10 people, then 3.8 of them are probably going to be in favor. So D, the mean, is just N times P. So it's going to be 10 times 0.38. So it is going to be 3.8. That is your average. We're going to have an average of 3.8 people in favor of stricter gun laws. Okay, the standard deviation, that one's not as straightforward. Okay, the standard deviation is the square root of NPQ. So have that in your note card. Okay, so the standard deviation is the square root of NPQ. So that is going to be the square root of 10 times P, so times 0.38 times 100% minus 38% is 62%. And this is just calculator, so go square root 10 times 0.38 times 0.62. And the standard deviation is going to be 1.535. Okay, E. Here we go, and I wonder if this one's on our table. So what's the probability that exactly 5 of the Utahns are in favor? Shoot, I think our 5, did our table say 0.1829266? Okay, let's try it on the calculator. Here we go. Your calculator, yeah, we got it right here. We've already done it. Binomial PDF, sample of 10, 38%, 5, it's going to be this guy, 0.1829266. So we got that done. Okay, now F is a good one. So F, what is the chances that more than 4? So on your table, we're looking at 5 through 10. We've got to add all these probabilities up, and that's a cumulative total. So on your calculator, we're going to go menu, 5, 5, and it's not going to be a binomial PDF, it is a CDF, a cumulative. Okay, so number of trials, that's 10. Chances of success, 38%. The lower bound, it's going to be more than 4. So it's going to be 5 all the way to 10 and hit OK. So I guess the hard part is knowing when to do a CDF and when to do a PDF. So this is 0.1829. 0.1829, so 18% of people, or the chances are 18% between 5 and 10. So you win if it's 5, you win if it's 6, you win if it's anything more than 4, you win. So you got like an 18% chance of winning. Now G, what's the probability that at the most 3 of them, now this is worded kind of tricky, do not want stricter gun laws? So 38% want stricter gun laws. These are people that are wanting stricter gun laws. Dun, 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 dun. So this is talking about the complement. Oh man, gee, this is a tricky question. Oh, G, how the crap are we gonna do G? Okay. Okay, we could do it easy if it was at most 3 of them wanting stricter gun laws. So maybe let's do that and then we'll just find its complement. So what is the chance that at most 3 of them want stricter gun laws? So we're going to go here and we are going to go menu 5.5. And it's a binomial CDF. Number of trials is going to be 10. Chance of a success is 0.38. The lower bound is going to be 0. Because I guess we could survey 10 people and none of them. So we could have a 0. An upper bound at most 3, so we're gonna go from 0 to 3. Okay, so that is 4336. So 0 to 3, 0.4336. So 43% of the people do want a stricter gun law. So we need to find the complement of that. So we're going to do 1 minus 0.4336. So 43% want a stricter gun law. And that means 56% do not want stricter gun laws. Okay. H, are any of the possible outcomes unusual? Explain. I don't know if this is, I don't know what this is. This is like a trick question. It kind of makes you feel like there should be one that's unusual. Let's try, and I guess in our table we should have put 0. Let's see what 0 says. So if we do, I'm going to go up and grab one of these binomial PDFs. And let's change that 10 to a 0. Okay. So the chances of you running into no one, if you survey 10 people, chances of that none of them want stricter gun laws is pretty small. It's a 0.0084, so this would be 0.0084. So that means 0.84%. None of them, the chances that none of them answer, yeah, I want stricter gun laws, is less than 1%. So that's, I don't know, they all seem usual to me. So I don't know what to put for H. Everything looks good. H looks good. Okay, number 4, this is where we're at right now, a normal distribution. So this is chapter 6, 6.1, 6.2. Okay, number of visits per day to a particular website is approximately normally distributed with the mean of 4,200 and a standard deviation. So mean right here, 4,200. Standard deviation of 1350. So if you start making your normal curve, one standard deviation is going to be 5,550. 2 standard deviations is going to be 6,900. 3 standard deviations, this is going to be 8,250. And if I go 3 standard deviations to the left, minus 1350, so that's 2850, minus another 1350, that's 1500, minus another 1350, that's 150. Okay, so something like that. Okay, now what are the chances of a probability that there were at least 4,500 visits? So x is going to be some random variable. with a normal distribution, the mean is 4,200 and the standard deviation is 1350. So these are the parameters. Okay, chances that there were at least 4,500. So it's kind of wanting this 4,500 somewhere in here and anywhere to the left of that. So this is going to be in your calculator. Here we go. We're going to go menu 55. It's a normal distribution and it's continuous. Okay, now your lower bound. Now this is a way good question. Your lower bound, I mean, 3 standard deviations, you got to remember this. Within 3 standard deviations above and below, that is 99.7% of everybody. So if I go much left of the 3rd standard deviation, it's not gonna mean much, because there's not a lot of people living outside of that 3rd standard deviation. I mean, there could be a chance that there is 0 visits on a website. This is per day, so there can be a day where no one visits, but that looks like it's, I mean, that's way small statistically. So let's show you what I'm talking about. So here we go. Lower bound. Let's do it with 0. So let's say there's 0 visitors. Upper bound. They wanted 4,500. The mean is 4,200, and the standard deviation is 1350. Hit enter. Okay, so that's a 59% chance, but I'm going to go up and copy this. Now check this out. If I change that 0, the lower bound, to 150, it's not really going to change a lot. 150. It'll change a little, but not much. Hit enter. Okay, so look, this is 59%, this is 59%. They stay the same until this one's 99, this one's 57. So 0.58, so it really doesn't matter which one you use. 0.587 versus 0.587. So B is 58.7%. 58.7% chance. Alright, C, and you gotta remember this inclusive stuff, it's irrelevant. Between 4,000 and 5,000 visits, that might be a question to throw you off. So 4,000 to 5,000, it wants this shaded area here, and there's really no such thing as inclusive, because it's inclusive or non-inclusive is going to give you the same answer. Okay, so between 4 grand and 5 grand, so menu 555, menu 55. Okay, we're gonna go, whoops, dang it. Distributions, normal CDF. Lower bound is 4,000. Upper bound is 5,000. The mean is 4,200. And the standard deviation is 1350. Hit OK. So these questions are freaking awesome with the calculator. So that's like a 28% chance of happening. Okay, D and E are the harder ones. Let's look at D. Oh man, my pad stopped working. Okay, D. Find the percentile for 5,000 visits. So really D is the same thing as A, but they want you to go, instead of going to 45 visits, 4,500, they want you to go to 5,000. So 5,000 right here, they want everything below. So if we take 5,000 visits, what percent is that going to be? So if I go up and copy this one, and I change this 4,500, if I change that to 5,000, Okay, so it's going to increase from 4,500. It's going to be like a 59%. This is, if I increase it to 5,000, it's going to be a 72%. So that is the 72nd percentile. So this right here is capturing 72% of all my data, so that's the 72nd percentile. Everybody lives there or below. Okay, now E, this is the $1,000,000 question. What is the number? If 5,000 visits is the 72nd percentile, what number is the 65th percentile? And that you hit, same thing, let's go menu 5, and this third one, that's the one we're going to do. We're going to inverse it. So we're going to go backwards. So inverse is if I know the area. So if I know my percentile is 0.65 and my standard deviation is 4,200 and my mean's 4,200, my standard deviation is 1,350, that will tell you right there 4720 is going to give you that 65th percentile. And that makes sense because I know 5,000 was 72, so it's got to be less than 5,000. 4,200, this right here is the median. That's 50%. 50% live below, 50% live above, so it's got to be more than 4,200, and it's 4720. Paching, pachang, and that is it for the practice test.